This video, we're going to explore systems of inequalities. Now, in a lot of ways, systems of inequalities is going to be very similar to systems of equations, but there are some key differences. The most important difference is the types of graphs that we're going to see. Instead of having multiple equations graphed, where they're just the line and we're looking for a point of intersection, we're going to have inequalities graphed, which changes things up a little bit for us because now we're going to have shaded regions as opposed to just the line itself. And to show you what I mean by this, I'm going to graph a system of inequalities on Desmos, where we're just going to take a few inequalities and graph them at the same time, so you can see how everything's going to look. So I might have something like x plus y less than or equal to, if it helps if I type it correctly, x plus y less than or equal to 4. I am having problems today, sorry. Less than or equal to 4. So that will graph our first inequality. I can add more to this, and I might say that maybe x is less than 5. It's going to graph another one. So far, anything that's in the purple and the orange at the same time would be part of our inequality and are part of our solution. So then I'm going to put another one here, y greater than or equal to 1. And you can see that the more I add, I'm still looking for an overlap of all of them. And it's actually just going to be this little sliver, actually this piece right here. It gets a little bit confusing the more you have because there's just so much shading going on. There's so many different things happening. So we're going to take a little bit different approach with what we do in our class. So first thing we want to do is identify what are these inequalities, which is which. So we're going to give you graphs. We're going to give you the inequalities written out, so just so we can identify which is which. So here we have the horizontal axis is labeled as C, and the vertical axis is labeled as L. So that's going to help us when we try and figure out these two, and then obviously um, by elimination we can figure out the other one here. So C is the horizontal one. That's going to be our vertical line right here, and so that would represent C is greater than or equal to 500. So that one would be B. The horizontal line is this one here, and that's going to be represented by L something. Oh, there we go. L is greater than or equal to 300. So that one would be C, and then our remaining one would be A. Now we can figure that out using our intercepts. We can find out where the C intercept is, which is at 950, again, if we set L equal to 0. And we can find the L intercept by setting C equal to 0, so that would also be 950. So we just wanted to verify we could totally do that. Let's go ahead and just listing our A, B, and our C. All right. So now what we want to do is figure out, based on the fact that we know that we have this A, we want to figure out where's the solution set to that inequality. Now again, it gets really confusing because we've got 3 inequalities that are going to be graphed at the same time. So we want to try and figure out a way to keep track of the information. Well, like we did in the last video when we looked at just basically a linear inequality graph, we're going to have to figure out where that region is. And once we've got that region figured out, we're going to look for some overlap between everything. So A, I'm going to start with that one. That one's this line right here. And I can test any point I want, but just like we did before, 0, 0 is a really nice point to try because it's very easy to plug in. We don't have to do a lot of calculations. So if I have the point 0, 0, and I plug that into there, I'm going to have 0 is less than or equal to 950. And that's totally a true statement. So I know that my region, my half plane for this solution is going to be here. So I'm going to just draw some arrows just so I know that for that red line, we're underneath there. Our next step then is to do it for the same ones, or the other graphs here. So for B, we've got C is greater than or equal to 500. So that's this one here. If I plug that point 0, 0 in, that's not going to be true. So this half plane is not the solution. It's the one that's actually over here. So far, it looks like this area in here is going to be our solution set. But we have that third one to take into account as well. And as we change the ink color, let's just go with the blue. I know nothing matches up with that lovely olive drab color, whatever it is. So we've got L is greater than or equal to 300. If I plug the point 0, 0 again, I've got zeros greater than 300. And not a true statement. That half plane is not our solution. So it's all this stuff in here. And it looks like right now, this area that we've got right in there is going to be where our solution set lies. Any point that's in there is going to be part of that solution set. So if we put an A in all the regions that work for the red one, good, got it. And a B for all the other ones here, got it. And a C for all the other ones. Yeah, anywhere we see A, B, and C in that same region, that would be our solution set. Now in this class, what we're going to be doing is that we're going to put an X there. Just because otherwise we have all these different colors and all this different stuff going on. It's much easier if we just have one indication of what our solution set is. So then what do we do with this? Well, the whole point of finding the area that's a solution set is that we want to figure out which points actually could work. So the way businesses would work this is they would have different values of production that they could use, and it's helpful for them to figure out if that's something that's feasible or workable that they can actually work with. So we have different production capabilities, whatever C and L actually stand for. We're not sure yet, and we'll get to some contextual examples in the next video. But if we take the point 200, 400, we want to see if it falls in this area here. Again, this is our solution set right in there. So if I go to 200 and 400, there's my point. Clearly, that one's not going to fall in our solution set. We know that A would not work. B is at 600 and 310, so we go to 600 and 310. It does look like it just fits in there. So I'm going to call that one a winner. We could also do 600, 400, so go to 600 up to 400. That point is just outside our region, so that one wouldn't work. We do 800 and 250 is here. Again, outside our region, that doesn't work. 550 and 350 would definitely fall in there. It's halfway in between the 500 and 600 and between the 3 and the 4. That one looks good. And then if we did 550 and 400, it looks like it's going to hit it right there. Now, that's where we got to double check our inequalities because they all say less than or equal to. Any point that's on any of these boundary lines would be part of our solution set. So F would also work. So what that tells us then is that those three values are potential values we could use. If we had something different, something outside of those values, we wouldn't be able to use them because they don't fit as part of our solution set. So let's take a look at another example here. This we have C and B. Same idea, except now it's a little bit more challenging because we don't have any of those horizontal and vertical lines, which again makes it a little bit easier to identify the lines. So we are going to use our intercepts method to figure out which lines we actually have. So when I've got C plus B is less than or equal to 60, I want to figure out which of those two lines on a diagonal it's actually going to be. So if I take C and I set that equal to 0, I can find out my B intercept. So that's my vertical line, or vertical axis in this case, would be 60. So I'm looking for the line that's going to cross at 60, and it appears it's going to be this one right here. So I'm going to mark this one as our blue line. That would mean that the other line, 6C plus 30B less than or equal to 600, would be this other one over here. And just to verify, if I found the C intercept, setting B equal to 0, 6C equals 600, yeah, it would be 100. So looks like we're good to go on those. Oops. And let me put that one in red. So let's find the shaded region and try and figure out which part of, looks like we got 4 different regions set up. We're going to figure out which one is actually the solution set. So because I've already got my red pen selected, I'm going to start with this line right here. And again, I'm going to plug in the point 0, 0 because it's super easy. So this becomes 0, this becomes 0. 0 less than or equal to 600 is a true statement. So I know that anything that includes the point 0, 0 is part of my solution set. Then I do the same thing for the other region, 0, 0. I've got 0 plus 0 is less than or equal to 60. So again, that's true. So anything down in here works out. And so it looks like my region that's part of my solution set would be right in there. Now we want to know, okay, which of the following points are part of the solution set to the inequality. So again, we're going to take, just like we did before, take our points and evaluate to see if they're in that region that's in here. So 55, 50 comma 5 would fit. We're good on that one. 50 comma 20 is a little bit too high. That one would not work. 20 comma 10 fits right in that region. 10 comma 20 just outside. Oh, that one doesn't work. 70 comma 2 is past 60, so that's not going to work. And 70 comma 10 also looks like that won't work either. It's out of the region in 2 places. So that's kind of a rundown of systems of inequalities. So again, we're going to graph both of them. Sorry, the graphs are going to be given to you, but we want to figure out which is which and then set up our regions. And I think those little arrows kind of help to give us a little bit of better view of it. But we're not going to be doing full-blown shading on this because it just makes it more complicated.